U2. So here is W1 which is connected to U2. So as you can see here, this is a delta connection. Hi, and welcome to electrical engineering. And in today's video, we will continue working on basic circuits, which is star delta circuit. And in the last video, we were speaking about what is direct online circuit. It's a very important basic circuit, but we used it only in small motors because of the inrush current or high starting current, also because of the voltage drop. So we are using it only on small induction motors and in huge systems. But in today's video, we will hit a new method of starting a three-phase induction motor, which is called star delta method. We're starting the motor with delta connection, and after a while we convert it into a delta connection. Why? Because when we are using star at the beginning, we reduce the inrush current. We reduce the starting current at the beginning, and when the motor started to be rotating at its synchronous speed or the actual speed, we're starting to convert the connection from star to delta because delta have higher torque at working. So we are starting as a star and then converting it into delta. Here, as you can see, this is a star connection. We are connecting the three windings from one end on one point. And actually, here the voltage across line to line is 380 volt. So the voltage across each winding here will be 380 volt over root 3. So the voltage here is equal approximately 230 volt. So the voltage is not huge at the beginning on each winding, so the current of starting will be not huge at the beginning. So we will reduce the starting current. But when the motor starts to rotate to its actual speed or synchronous speed, minus the slipping of course, we will convert it into delta. Because every winding here in the delta connection have the 380 volt. So the 380 volt, which is the line-to-line voltage, will be at each winding. So we will have the full line-to-line voltage on each winding. And here actually the torque of the motor is proportional to the voltage across each winding square. So when we increase the voltage across each winding, it will increase the torque twice. So this is perfect. Let's now start creating our power circuit and control circuit to start the motor as a star delta. Now let's start creating our power circuit and control circuit. As you can see here, this is our motor. It has here U1, V1 and W1, and here we have U2, V2 and W2. And as you know here, U1, U2 has a winding, V1, V2 has another winding, W1, W2 has the third winding. Perfect. This is W2. Now, let's connect our power circuit. Here, as you know, we have a three-phase power, R, S, and T. We will connect it first to the main circuit breaker. So here, this is our first main circuit breaker. And then we will connect it here to the main contactor. So this is main contactor. I will call it K1. Okay. Now after this we will connect it to the overload. So this is OL1. This is overload. Let's now connect it to U1, V1 and W1. So as you can see here, RST is connected to U1, V1, W1, or L1, L2, L3 is connected to U1, V1, W1. Now let's create the rest of the circuit. Now we will bring another contactor and a third contactor. So here we are using 3 contactors. This is the delta contactor. I will call it K2. And this is the star contactor. And I will call it K1 or K3, I'm sorry. So here we have 3 contactors. K1, which is the main contactor, and K2, which is the delta contactor, and K3, which is star contactor. Now let's connect K star. Here, as you can see, at one end of the 2 ends of the contactor, we will connect the 3 points together. So here we are having only 1 point here. So we are connecting them as 1 point. On the other end of the contactor, we will connect it to U2 and to V2 and to W2. Perfect. So as you can see here, this contactor is connected to U2, V2, W2. When this contactor will be closed, those U2, V2, W2 will be shorted, will be 1 point. So this is a star connection for the motor. Perfect. Now let's connect the motor as delta. Here we will bring the R. Let's do it with another color. Here, this is R, and this is S, and this is T. Let's connect R here, and S here, and T here. Okay, now we have our connection RST to the first 3 points of the delta contactor, K2. Now let's connect the other ends to U2, V2, W2. But I will connect the first terminal here to V2. Because I want to connect U1 to V2 and V1 to W2 and W1 to U2 to have the delta connection. So here, this is S, which is connected here to V1. I will connect it to W2. Also, W1 here, I will connect it to what? To U2. So, if we draw the windings now, we will understand. This is our windings. Here, for example, this is the first winding, which is U1 and U2. Now I have connected U2 or U1 to what? I have connected U1 to V2. So this is V2. So this is the second winding, V2 and V1. And V1 I have connected to what? To W2. So this is W2. And W1 is connected to U2. So here is W1, which is connected to U2. So as you can see here, this is a delta connection. So when this contactor is closed, it will connect U1, V1, W1, U2, V2, W2 as this connection, which is delta connection. So we will start first to create this contactor to be closed and connect the star contactor at the beginning to have a star connection. Then we will open the star and close the delta while the main contactor is closed. At this point, we will convert the connection from star to delta. And this is the idea behind the star-delta connection. Now, let's say that we are using a 220 volt on the control circuit. So, we will bring R or S or T or whatever. This is line, R or S or T. And this is neutral. So now we are having a 220 volt, which will be useful for the coil of the 3 contactors. So we will buy a contactor which have a rated voltage of the coil of 220 volt. Now let's connect our circuit. Now we have a circuit breaker, let's call it circuit breaker 2, which is a single pole circuit breaker. Then we will connect an emergency stop button. This is stop button. This is a normally closed emergency stop button which is used to open the circuit as emergency. Now let's connect OL1, which is the overload. It's normally closed auxiliary contact from the main overload here to open the circuit if anything bad happened. Now let's bring our start push button. This is start push button. Now let's connect our main contactor, which is K1. This is the coil of our main contactor. So here when I start the push button, here I will close the circuit breaker first, and when I push the start push button, it will energize K1, so K1 here will be closed. But when I release my hand from the start push button, it will open, so it will open the circuit again. So I will bring a latch or holding contact here, an auxiliary contact from K1 to be parallel to the start. So when I press start, this will be energized, which will close this main contactor, and this auxiliary contact will be also closed, which will provide a new path to the coil of the contactor. Now let's create another thing, which is called what? Which is called a timer. This is a coil of a timer. I will call it T1. So actually this is our timer now. I will use this timer, an on delay timer, to count the time. I want at the beginning to make the motor start as a main contactor will be closed and the start contactor, which is K3, to be closed. And after a while of time, this will be open and it will close K2. So I will use this timer as a time counting that will help me to create this K3 at the beginning to be closed and then open it and close K2. Now I will take a point here and connect it to a normally closed contact from the timer T1, and then connect it to what? Connect it to K3, which is the start contactor. So at the beginning, when I start the motor, the current will flow to energize K1, okay, and it will provide a new path to K1, and the timer will start to count. While it's an on delay timer, it will not open T1 until the time will be end. So for example, if I give a time of 10 seconds for this T1, so at the beginning this auxiliary contact T1 will be closed until the 10 seconds. After 10 seconds, this T1 will be open because it's a normally closed contact. So at the beginning, K1 and the K3 will be closed. After a while, I want this T1 to open this and close a new circuit, which is what? Which is K2. So now I will connect here a new path to normally open T1. This is normally open, and connect it here to what? To K2. So as you can see here, when I close this start push button, it will energize K1, and this K1, when it's closed, it will close the main circuit breaker, and it will close this K1. So the current will move from this new path to K1. At the same time, a new current will go to energize K3. So this K3 also will be closed. So the motor will start to rotate because it has a closed loop, but with a star connection at the beginning. So now we are star. And this timer is starting to count. After 10 seconds, for example, it will send the signal to T1 to be open, and this T1 normally open to be closed. So now what will happen? K3 will not be energized, so it will open, and this K2 will be closed now. So now we are connecting our motor as delta connection, which have higher torque. So we started with a star, then we are converting to delta, and all this time K1 is always working because it provides the path to U1, V1, W1. So K1 is always on. Then we are connecting K3 at the beginning to start as a star, and after 10 seconds, for example, we are getting this K3 off and K2 will be on. So K1 and K2 now is working as delta. Perfect. Now, what if, for example, this timer has a problem? This contacts doesn't work properly. So let's say, for example, at the beginning we were working as star, and when this timer starts to give an order to this contact to open and this contact to be closed, let's say, for example, and this contact doesn't open, it has a problem. Now K2 and K3 will be energized at the same time. So this contactor and this contactor will be closed at the same time. So here we are creating a short circuit because this have a three-phase power or an SNT, and then we created a short circuit on this 3 points. So we made a three-phase short circuit now. So we can't make this K3 and K2 work at the same time. But if T1 has a problem in its contacts and it doesn't work properly to open and close, this will create a big problem for us because it will create a three-phase short circuit because K3 and K2 will work at the same time. What we can do now is creating something called electrical interlock. So we are making something called interlock, like the mechanical interlock, but with electrical features. So we will have a new points here in this circuit to ensure that K2 and K3 will not work at the same time. Even T1 has a problem in its contacts. So now I will make a modification on this circuit. At the beginning we said what? We said this T1 is normally closed and this T1 is normally open, and this is our timer. So this is K2 or K3 at the beginning, and this is K2. Now I will bring an auxiliary contact from K2 here, normally closed auxiliary contact, and connect it in this circuit, and I will bring a normally closed auxiliary contacts from K3 and connect it here. Now let's say that we have started or press this start push button. So K1 will be working. So this contactor will be working. So it will close this K1, which will provide a path to this K1. Also at the same time T1 is counting, but it will not make an order to open T1 normally closed or to close the normally open until the time ends. So K3 will be working at the beginning because T1 here is normally closed and this is normally open. So it will open this path here at the beginning to ensure that K3 and K2 will not work at the same time, because this is a normally closed from K3. K3 when it's working, this normally closed will be open. After a while, when timer T1 is open and this one is closed, when T1 is open, this K3 will not be energized, so it will return this K3 to its original state as a normally closed. So at this moment, this K2 now is working, which is the delta contactor. So it will open this normally closed contactor K2 to ensure that K2 and K3 is not working at the same time. So let's say, for example, that T1 here, the normally open and normally closed have been closed at the same time because it has a problem in its contacts. K2 and K3 will ensure that only one of those contactors working at one time. So it has made an interlock between K2 and K3. Even a problem happened on the timer contacts, K2 and K3 will not work at the same time. In the upcoming video, we will learn how to make a motor rotate in one direction or in the other direction. Also, we can connect the same motor as star delta also. So we can connect the motor as star delta, and also we will reverse the speed of the same motor. So stay tuned for the upcoming videos and consider subscribing in Electrical Engineering Planet channel to support our community. Also don't forget to share, like, and let knowledge enlighten your world. Thanks for watching.